So in part B, we're given that on the interval between 0 and 5, it can be shown that the height is larger than 1. And we are told that at some value t in this interval, h has a critical point. We need to find the time at which this critical point happens and whether it is a minimum or a maximum. So what we notice is that the differential equation is given in this form, where it's 1/2 times h minus 1. We are told that h is always larger than 1, and therefore this term here cannot be equal to 0, and then it will be multiplied with cosine t over 2. So if this cannot be equal to 0, then the only way this can be equal to 0, this derivative, so it has to be a minimum or a maximum, so it has to be 0. So the only way that's possible is if cosine t over 2 is equal to 0. And well, we know cosine pi over 2 is equal to 0, therefore t is equal to pi is indeed between 0 and 5, and at that point the derivative will be equal to 0. Therefore this is a critical point. And we also need to determine whether this is a local maximum or a local minimum. And well, what we notice is that on the interval for t between 0 and pi, our derivative is always going to be positive. So dh dt is always going to be positive. We can also see that from our slope field. It only has upward sloping lines, so that means a positive slope. And what we know is that after pi, so on the interval pi to 5, our slope is going to be negative. We can see pi is somewhere over here, so here we're going to have a negative slope. We could also see this from the function itself, considering where cosine is positive and where it's negative. And therefore, if we have a point, so point, this is at pi, before pi the slope is positive, which means the function is increasing. After pi the slope is negative, which means it's decreasing, which means it must have a local maximum point. Therefore this point is a maximum.